Two Catalan companies, Trama Tecnoambiental, an engineering consultancy, and a local centenary utility company, Electra Caldense, in collaboration with several research centers across Europe, have developed a new generation of solar energy systems to generate electricity, incorporating eco-design and smart control principles.
Trama Tecnoambiental és una PIME fundada a Barcelona el 1986, especialitzada en l'aprofitament de les energies renovables i en el disseny i gestió d'edificis sostenibles.
Electra Caldense és una empresa de distribució elèctrica. Va ser fundada l'any 1917 per un conjunt d'empresaris i calderins per tal de poder donar subministre en qualitat i quantitat de subministrament elèctric. Després de la crisi del petroli del 73, que vam començar també a moure's a nivell d'energies renovables i concretament ja promocionant tema hidroelèctric, i quan ens vam plantejar aquest projecte ho vam veure molt interessant perquè veiem que la generació distribuïda és un projecte de futur no només a Europa, que és molt important perquè no hi ha altres tipus de recursos energètics, però també a nivell mundial perquè pots fer-ho, estendre-ho a tot arreu, perquè és una capacitat de captar energia de forma universal.
El paper de Trama Tecnoambiental ha sigut convertir aquestes lliçons apreses en el camp teòric a petites experiències pràctiques que serveixin no només per validar la teoria, sinó per fer avançar aquests coneixements teòrics i apropar-los en el mercat.
The first system of its kind has been operating since April 2013 at Electra Caldense's warehouse in Caldes de Montbui near Barcelona. It is a photovoltaic system, also called PV system, that can operate in several modes and therefore be adapted to fit all types of consumption patterns and load profiles, as well as be compliant with eventual changes in legal framework of grid connection. It also includes an advanced lithium-ion battery, which is 10 times smaller and can last double than conventional batteries and is much safer. Even though the system can be programmed to operate under many possible strategies, the recommended configuration is to first utilize all the electricity generated from the PV modules to feed the loads, in this case, indoor lighting in the warehouse. In case the load demand is lower than solar radiation, for instance, on a Sunday morning when the warehouse is closed, the PV generation charges the battery. If the battery is full and there is still PV generation surplus, this surplus can be sold to the grid. In case of insufficient PV generation, either because of low solar radiation or lighting demand exceeding the PV generation, the loads are then supplied both from the PV generation and from the battery. If the high consumption remains after the batteries have reached 20% of its capacity, then the grid takes over and complements the PV generation to feed the loads without a blackout. The power conditioning unit, composed by a charge controller, a bi-directional inverter, and a battery supervisory system, is the real brains of the system, responsible of the monitoring and management of each component. Such advanced intelligent control enables the optimization of the system performance under any possible technical or regulatory condition, including tariff structures with differentiated day and night rates. Besides, the design of the system is based on D4R criteria, that is, designed for reuse, recycle, refurbish and repair, to enable the use of byproducts from other sectors and to avoid as much as possible the generation of waste during the lifetime of the PV system. As an example, the structure that supports the PV modules has been built from reused metallic profiles obtained from an old printer manufacturing line. The overall efficiency of the system has been increased to almost 65%, which is 10% higher than the best current PV installations, and its expected lifetime has increased from 20 to 25 years. Furthermore, due to the industrial synergies achieved, this new solution has reduced the greenhouse gas emissions and the water consumption levels associated to its manufacturing by 40%, and has enabled a rate of reuse and recycling of components over 90% with respect to conventional PV systems. This solution has been developed within the ZeroWIN research project, funded by the European Commission, Trama Tecnoambiental and Electra Caldense.